Cool. Okay. So for those who don't know me, I run a company called Claritize. We do big data. I don't claim to be an expert in this whole field. It's an absolutely massive field. And I am going to make this presentation more interactive. So I'm going to be asking every one of you questions, not individually, but as a whole. So you don't have to worry, I'm not going to pick on anyone. The reason why I want to make this interactive is because this is such a big field, I don't believe that any one person knows this whole field. And I think if anyone does say they do, they're probably misled. The truth is, this field is moving so rapidly, and there's so much innovation going on, that there's bound to be someone in here that knows a bunch of tools that I've never heard of, and vice versa for everyone you in here. So anyway, my first thing was a joke, which doesn't work because it wasn't raining when I got here, but when I was writing the slides earlier today, it was in fact pouring down with rain, so thank you to those who swam here. But anyway, what I'm going to go through is the history of big data, the current state of play, and where I believe we're headed. Now, I'm not going to predict which tools are going to take off. I am going to tell you about some cool tools that I know about. I'm going to particularly concentrate on cool tools that I know about in the local area. So for those who don't know about and there's some amazing local startups doing some really clever big data stuff. I am going to mention them because I obviously want to promote the local area, but also because I think some of these tools are really, really cool. First question I'm going to ask is, what is big data? And so I took this from Wikipedia, and actually I keep noticing the term and definition on Wikipedia keeps changing. So this is their current definition. Big data is a broad term for data sets so large or complex that traditional processing applications are inadequate. So the issue I have with this, and I guess some people are probably having problems with the word big data, is actually what is traditional now. Hadoop's been out quite a while, so I guess we can say that traditional is possibly Hadoop now. But anyway, I guess we all know that processing data in large volumes has changed quite a lot recently, and the volumes are getting larger and larger. So just a quick show of hands, who regularly processes data where they're considering more than 1 million rows at a time, where they're doing some sort of select or batch processing on more than 1 million rows at a time? Just out of interest. Okay. More than 10 million or 100 million? Okay, more than 1 trillion? Okay. So I guess this is probably my understanding as well. Is actually, we have a lot of tools that deal with big data, but actually a lot of people just deal with processing data. So I'm going to propose actually we forget the term big data for the presentation, and we just consider data processing. For most of us, we deal with data which is, it might not be super large. Some of us deal with super large volumes. I think the guy there deals with the biggest volumes out of the hands up here. But I do think that we all process data in some way. Just out of interest, how many people deal with data processing at all, or do a job where they're... So that's, okay, sizable majority actually. Cool. Okay, so I think originally big data was defined as a lot of the new technologies such as Hadoop that basically allowed processing in a way that wasn't allowed before. So for those of us who have been around in software development for a bit longer, probably know the old way of doing things, which was you basically had Oracle or Sybase, and then you did a bit of chunky processing. And the issue you had was the size of the data you can cope with basically depended on the size of the machine. And when you wanted to process more, they basically bought a bigger machine. So you'd get a Solaris machine that was about as tall as me, and I'm not that tall. And you'd basically put Oracle on it, and you'd try and process as much as you can. And then Hadoop came along and basically flattened it out. So just go to the next slide. There you go, we've done the data. So basically the history is, as I don't want to insult people who already know this, but Google released quite a few white papers which describe their big table, Google filing system and MapReduce concepts. And then a couple of guys at Yahoo wrote Hadoop based off the white papers and released it to the general public. So Google designed their big table and Google filing system and MapReduce to basically to underpin their search engine. And they have a particular problem that they were trying to solve, which was they were data mining the whole of the web, bringing back huge complex websites, particularly having large volumes of text in it, and being able to search for it super fast. And they were specifically trying to solve that problem. Yahoo had exactly the same issue, so they took Google's white papers and then basically built Hadoop, and then Hadoop got open source, and then everyone started using it for everything. The issue was And I think a lot of people, so just out of interest, in this room, how many people have used Hadoop? No, it's not that many. Out of the people who've used it, who thinks it's hard to use? Actually, who knows what Hadoop is? Okay, who would say you understand the concept of MapReduce? I'm not going to test anyone, by the way. Okay. All right, I'm going to give a quick overview because there's quite a few people who didn't know. So the idea of MapReduce is you take a complex calculation. Maybe you're doing things like, I don't know, counting the number of people that are over the age of 10. And if you have a distributed filing system, you're allocating components of work across the processors on the distributed filing system, doing the calculations on that as a distributed system, and then bringing the data all back together and combining it together to produce a number. Now, the reason why that solves scaling issues is instead of the old way of doing it, which you have a massive server and it basically goes down on the whole server, you're spreading the load across servers. And what that gave us is the ability to add new cheap hardware and scale stuff out very cheaply. So does anyone have any questions on Hadoop? Just so that it's really hard to know what everyone's experience level are. So, but any questions? Does anyone have any questions so far? But do fire them away. I don't want questions at the end if possible. But you can do questions at the end, but I'm not saying absolutely no, but I'm encouraging them as we go on. So what did this generations of tools do for us? So as everyone knows, the word and term big data went a bit bonkers. Everyone went big data crazy. I did a Google search on the number of search terms for big data failure. I did big data failure 2012, big data failure 2013, 14 and 15. As you can see, there looks like there's more failures going on. I think a lot of people have tried these tools and had issues with them. Hadoop solves a very particular type of problem. If you're using Hadoop for those types of problems, it's absolutely amazing. There's loads of other problems it doesn't work so well for. Okay, so also, who's involved with something related to the Internet of Things? Okay, maybe about 5 to 10%. Does everyone know what Internet of Things is? Okay, cool. So I guess, hopefully, we all suspect it's going to increase, right? So how many people have got a smart meter in their home? Okay, oh. Have you got the Nest one? Has anyone got Nest? Is it good? Is it? It does, I must admit, it does look pretty cool. So anyone who's not seen Nest, check it out online. I think they're ex-Apple people, aren't they? It's been basically bought by Google, I think now. But it's an amazing product, and basically it's like an Apple product, which is a thermometer on your home. Fantastic. But anyway, the idea is we're going to have Internet of Things. All of our devices, and you know, the thermometer's one in your house. We're going to have billions of devices all collecting data and sending it to a central location or specific locations, and we're going to need to process that data because it has value in it. So Internet of Things is going to keep pushing up data volumes. So given that, where are we headed? And this is where I'm going to go through some cool technologies. And again, I do apologise for those who I'm giving too much information. I also apologise for those I'm giving too little. But because the group is quite a range group, I'm going to have to kind of do it quite high level. So I'm going to go through processing technologies, storage technologies, SaaS versus deployed software, maturing of deployment technologies, so VM containers. Well, I'm not actually going to talk about that for this. And the next generation of big data software, which is basically, I believe, moving from platforms to automated tools. Processing technologies. So, again, how many people have used Hadoop? It was a few. How many people have used Spark? Okay, so about 3. There seems to be a lot of innovation in the Hadoop space. Hadoop did solve a few problems really well. It was a bit of an immature technology at the beginning. I don't know, for those who've used it, how you found it in terms of managing production deployments, but it wasn't easy at the beginning. A lot of companies like Hortonworks help with those sorts of things a lot. I guess it's maturing a lot now, and you're getting technology like Apache Spark to help solve some problems that Hadoop didn't solve in the first place. One of the interesting things that's coming along is a concept called micro-batching. So MapReduce and Hadoop is a batch processing system. And batch processing really is, you want to process some data, you kick off a batch, it comes back and gives you the result. That's quite different to kind of event processing, which is the event comes in, you process it and you move it along. And because of this, what people found was they'd write data in Hadoop to do some processing, give them like results from a report, and then they'd go and write that report in a different tool when they wanted to online features in a dashboard. And so to get around this, there's a concept of micro-batching that's been introduced, which is you do things in super small batches, but it's almost pseudo real-time. Am I going too technical? No? Cool, okay. Often with batch processing, throughput is often more important than latency. And definitely in this area, with Hadoop, I expect the platforms to mature and become easier to install, configure and use as time goes on.
Can you explain that? Because throughput and latency seem to be linked to me.
Yeah, they are. So I guess throughput is, say for example, if you want to do 1 million rows a second, right? You need to do those 1 million rows within the second. Now, you might not need a sub-milli time response. So when you go onto a website, those adverts appear instantaneously. Now, with those, latency is absolutely key. If those adverts don't appear fast enough, or the bidding doesn't happen fast enough, those adverts won't appear. So that's a case where latency is key, i.e. the response of, it has to respond in sub-milliseconds. Throughput is, you need a certain volume by a certain time. So I don't need it respond within milliseconds, but I do need 100,000 done within a second. So if they arrive dead on the second, I'm still happy. Whereas with latency, you might, so financial services, price tickets, latency is absolutely key. If the price is too late, you don't want it anymore. So stream processing is often more important if latency is key. So throughput might not be as large volume, but actually if an event comes in, so in a hospital, if an alarm goes off on a monitor, you don't want it 5 minutes later. You don't care whether it can do 1 million alarms in 5 minutes. If the alarm comes in 5 minutes late, it's no good to you. You know, the patient's been ill for 5 minutes. How many people use Storm, Apache Storm? Okay, so just the one. That's less than I thought. So Apache Storm is a great example of a stream processing technology where the events come in, and it's typically, they talk about it's good for doing complex event processing. Event comes in, you do processing, it goes out the door. And with Hadoop, Spark streaming is kind of almost the Hadoop version of Storm now. Has anyone used Spark streaming? Well, there's literally no one. Innovation in messaging technologies. Has anyone used JMS? Okay, so a few people using JMS. How many people are familiar with messaging technologies? Okay. This is one area where there's started to be some innovation. How many people have used Apache Kafka? Okay. And you've got it working in the...
With Star, yes.
Oh, really? Did the API... Because the APIs are changing every... So, if you're going to check out one thing tonight when you get home, I recommend checking out Apache... Well, Apache Spark is good, but Apache Kafka is great as well. I think it's really going to come of its time. It's a fantastic messaging technology, and I think it's going to be used more and more in different technologies. The one thing I would say, the APIs are changing at a blistering rate, though. So I know they just did an upgrade and it just basically broke all my APIs. And
it's a terrible name.
I know, I keep calling it Apache Kafka. So anyway, I think there's going to be huge innovation in messaging technologies. And I'll go through the other technologies in a minute. But recently we've seen a huge innovation in DB technologies and processing technologies, like stream processing with Storm and Apache Spark, containerization for deployment type stuff. And I think messaging technologies is long due a big change. So data store technologies. I know there's a few database experts in the room. How many people are familiar with using an SQL database? Right. We've given them a bit of a bashing in the world of NoSQL, but actually I believe that NoSQL originally stood for not just SQL, not only SQL. And I think it meant to include SQL as well, but it seems to have morphed into not SQL. I don't quite know why. There are other great database technologies around now as well as SQL, and actually SQL is great for doing certain things. Data validation and stopping you kind of put loads of junk in your database. How many people have used a document store and got really frustrated when someone started just dumping junk in it? So a document store doesn't necessarily have the validation that an SQL database was. If you put constraints on an SQL database, someone put junk in, the database would reject it. With document DBs, you can get around that. You can put junk in. Has anyone used a column database? Cool. Okay, a couple of people. Graph databases. We have an expert in the room with Andy there. Okay, so what was it? One person? Okay. How many people know what a graph database is? Okay, a few more than have used it. So, graph databases are really interesting. I'm going to argue in a minute that one of the things I think the analytics industry is going to is a way where the applications understand the domain of data that they're processing. And I think one of the things that could support that is a graph database. So my conjecture is graph databases are going to have their time soon. I think they're great for certain applications. They're not useful for every scenario, but for what they're good for, they're absolutely amazing for. And I've actually just compared the databases here. I'm not going to go through them because I suspect everyone knows the differences.
You know what column DB is?
So a column DB is, instead of storing everything as a row where the rows join together, it joins, the column is everything, so you look in the bottom here, it basically joins the column as a stream. So speeding through the column is super fast. But if you're trying to join the row up, it's not great so much for joins. But it's fantastic if you're trying to, I don't know, search for someone called Johnson in the name row. And interesting, how many people here have heard of a company called Just One DB? Okay, are you a Just One DB person?
Yes.
So that's a technology I'll talk about in a minute. But so I believe, and you can, as a probably techie, you probably know more than me. But I believe you guys, it's a combination of almost an SQL and a column DB. You index it both ways, don't you? Is that?
There's like a secret source. I don't know what to talk about.
Okay. Okay, but basically, I think there's a few really clever innovations going on that mean that you can have, for example, with Just One DB, the power of an SQL database and the kind of reading of an old traditional one. I think innovation in DB storage will continue. SQL DBs are improving a lot as well. So I think they rested in their laurels for years, but I think now you're starting to see scaling out of SQL databases. Document DBs are amazing at some applications, especially where the schema changes rapidly, but they can be misused, and I've seen them be misused. Column databases are innovating at a fast rate of change, including hybrid ones. And graph databases are amazing in some specific applications. And I expect the graph databases to become more popular. And I'll give you a fantastic example of its use in a second. Yeah, so I guess there's no one answer fits all in terms of databases. Yeah, there's going to be lots of innovation database-wise. Right, SaaS versus deployed. So this is a really interesting debate. How many people are working on a product that's SaaS at the moment? Okay, how many people are working on a deployed type product, deployed piece of software? Okay, so that was still more deployed. The guys who are working on deployed software, are there plans to move it SaaS? Okay. For those, not sure. For those who are working on SaaS, is there plans to make a deployed version? If there is one. Okay, there wasn't one yes I could see there. I think the general feeling is tools are moving SaaS. And if you look at the industry in terms of big data analytics tools, for example, the ETL tools like Talend and analytics like Tableau, they have SaaS versions and deployed versions. The SaaS versions tend to be a bit lighter weight than the deployed versions, but they're catching up very rapidly. How many people use Talend out of interest? Okay, I'm surprised at that. Some tools are SaaS only as well. Does anyone heard of Import.io, just out of interest? That's another great tool to check out. Basically, you throw it at any web page and it will process the web page and turn it into a database for you. So you can throw it at IKEA as a website, and it will churn it back as a product database for you. It's a great startup. I also expect innovation in this area. Does anyone heard of a company called Zinstra? Okay, so it's a great Bath-based startup, and what they've got a really mental piece of technology that basically is a server that sits in your corner and pretends it's on the web. So instead of having your software on your machine, it's on that box there, and your machine thinks it's going to the web for stuff, but it's actually going to that box there. Now, you guys are probably sitting there going, well, that's the reverse of SaaS. That's like the reverse of cloud. But actually, if you look at technologies, and every piece of technology we build, we put layers of caching in, right? So, your CPU's got some fast RAM on its CPU, and it's got some slower RAM, and then it's got its main RAM. It's almost like a cache box. So the internet doesn't quite respond, but the software's local, so it responds almost like a cache. And I expect there's going to be other innovations like those technologies coming up. It's a great company, check it out. Next generation of automated tools. I'm almost finished, by the way, so I do like to rush these things, but anyway, just make sure the pizza's here in time. I'll be like 12 minutes early. Okay. So where the market is headed. Over the next few slides, and there's not many left, I wish to argue that the next generation of services will be built upon platforms which typically use machine learning and other techniques to understand data and schema. How many people are involved with data and do things like ETL? So extract, transform and load. Okay. It's quite a manual task, isn't it? And the problem is you really need to understand the data. So just taking a step back again, how many people deal with data on a regular basis? Right. So if you're dealing with data, you understand the data, right? If you threw a computer at it, it would just go, well, I don't understand this. And the value you add often is you understand that data. And definitely when you're pulling data out of something and you want to do analytics on it, the tool that's going to do the analytics needs to understand the data. So you either need to tell the tool or you need to write the analytics for the data. And I think one of the big range of changes that could come is applying machine learning techniques to understand data before it comes in, and then having automated tools that can do things on the data. And you're already starting to see this. It's a frightening piece of technology, but I think that the value-added tools that can go on top of this will be phenomenal. Import.io is a classic one. It tries to understand the data. When it's thrown at the IKEA website, it tries to work out. Imagine getting a table and you don't know which way the columns go, right? So Import.io, when it imports it, it goes, well, the price seems to be consistent down this way, so I think that's a price. And maybe there's only 2 decimal places after the point, I think that might be a price field. And just using clever inference to work out what something is. So with ETL technologies, the best in breed at the moment are things like Talend and Pensaho, and they're heading towards more SaaS tools. But there's a next generation of tools which are coming along. Trifactor is a fantastic tool. So anyone who's doing ETL at the moment, basically what you do is you load up your database into Trifactor. It works as a SaaS product. It tries to take clever statistical guesses on what your data is and what the transformations are from the columns you've got and the data inside the columns to what you're trying to get to. Right? So the ETL task, which if you're doing a massive project on big data analytics, tends to be one of the biggest tasks. A tool like Trifactor could do that in theory, that part of the work for you. Well, at least it will be like a clever wizard. Again, I mentioned Import.io because they, again, use machine learning technologies to work out how the data is structured on the website. If you think about how data is structured on the website, it's incredibly easy for a human to understand, but for a computer it can be quite hard. Recognising what's a table, recognising what values are in what parts of the table, knowing that something is a date. How many different formats of a date are there? You can spot it immediately, but a computer, it's harder. Has anyone heard of a company called Ontology? Okay. Oh. So Ontology is a great company, and they use techniques like a graph database to see structures, and they tend to be in the telecoms industry, that they've seen before. So they recognise the idea that they go for is it's basically super fast integration. So they connect to a system and they recognise the data, the domain of data, and what the data's about. So immediately they can start providing higher level value. Instead of you going, I know this is a sales database, therefore I know that this column, which is the sale item of a value, is the important one for my customer. Imagine a computer that could do that. It could connect to your database, work out what's the sales table, work out what the sales column is, and actually give you an automated report back again. Could put us all out of our job, hopefully. Analytics, and this is my area of love, I guess. There's current best in breed, which is things like QuickView and Tableau. How many people use Tableau, out of interest? So Tableau is a great tool. If you want to do a dashboard, it's a fantastic tool. There's a SaaS version and a deployed version. And Claritize do this, but I think there's other companies doing this as well. I think the next level of analytics tools are going to be doing things like automated data mining. So, just out of interest, how many people know what data mining is? Okay, it's a few people. So I guess data mining is a machine traversing through data to find value in that data and then presenting it back. So typical things you can do with data mining, such as anomaly, I can never pronounce that. You can read it. Anomaly 42. It basically finds anomalies. So it'll look through data, work out what's normal, and then spot things that are slightly abnormal. Great thing for data mining to do. For big data projects, they're actually incredibly difficult in terms of when you do a big data project, you have to do a whole transformation to get the data in the right format, process it, and then find value. Things like data mining tools like Anomaly 42 and also Claritize, there's going to be loads of others coming. We'll be doing the automated trying to find the value in the data. It's actually incredibly hard. Again, it's another section where I think machine learning is really going to help.
I know, just remind me of something that was in the news the other day, it might have been yesterday, that they're saying how many scientific journals are published, or just even medical journals it might have been, every year. It's like millions, and they reckon that something like 90% of them never got read by anyone other than the person that wrote it. And they just said that all that data, and there's no way of knowing, if you pulled together data from all the different sources, whether you could come up with some really useful findings, like cure for cancer or something like that. It's exactly that kind of thing.
Yeah,
and they're talking about having a machine
learning
way of exactly what you're talking about, automated data mining.
There's a company that I know really well in Bath called SciTab. Has anyone heard of SciTab here? So it does exactly that, but does it for particular types of medical journals. So they look for antibody reports, and what they try and spot is where antibodies have been referenced and the combinations of where they're useful. So does anyone here know the world of antibodies? It's a bit mental, apparently. So as it turns out, every drugs company produces the same antibodies, but because it's not standardised industry, they all call it different things. So one company will call it an apple, one call it a banana, one call it a grape. If you're a researcher, you don't know that this apple is this banana, is this grape. So when you do your test, you have to go to drug company A and get apple, drug company B and get a banana, drug company C and get a grape. It means that you have to overspend by however many drug companies are. It's completely bonkers. What SciTab do is they traverse through reports and basically work out the cross-references of what antibody is the same as the antibody in another company. It's a genius idea. Again, it's a form of data mining. Device app monitoring. Does anyone use Splunk here? No one?
Yeah.
You use Splunk?
I don't use it directly, but okay. Yeah, it is kind of...
I have to be really cautious with that word. We were chatting about it on Skype the other day, and Hannah, one of the people that works for me, actually ended up putting a little asterisk on our chat and just said Splunk, just because a couple of people spelt it wrong. I think the autocorrected. But anyway, so does everyone know what Splunk is? Because I can give it. So Splunk is basically a really clever log processing tool, right? So you've got, say for example, you've got 5 machines and they're all kicking out loads of logs. You don't know where the error is in your application. Splunk basically processes all the log files, so you can search it. I guess similar to Elasticsearch, if anyone uses that. Anyway, again, and this is my penultimate slide. It's another industry where machine learning is going to massively change the whole industry. So there's some great new players like log entries. And what they do is they look at your log and they use machine learning tools to work out what's normal in your log file, right? And then they spot when there's odd looking things in your log file. So if you've got an application that's suddenly written out error, this class, be nice to user, big error, and that combination has never happened before, it will alert you. And the guess is that something bad has happened and you've upset a user. Now, how many people tend to look at log files before they've got a problem? I guess it's none of us. And the idea with companies like this is that the idea is to catch it before there's the customer's got really irate and come round and come to see you at night time with a baseball bat. Anyway, that is the summary of my super fast presentation. I generally think being told I'm quick is not a compliment, but at least with presentations, I like to hope that I've not bored anyone. A quick summary of kind of what I've gone through. I think there's lots of the platforms like Hadoop and those sorts of platforms I think are going to mature more. You've got some really clever technology like Spark and Kafka coming out. I do recommend trying them, they are great technologies. I think there's going to be continued innovation in several tech areas: data store, processing technologies, messaging technologies, containers. I think the direction that big data analytics is going in is new automated learning tools. And if you look at each domain, I think there's a product for each domain with a new automated learning tool product that's coming out. And so I guess expect machine learning and other statistical algorithms to be used more widely. And I believe the crux of the future is graph databases holding common databases and what they've seen before to actually work out what the domain is so that the right kind of algorithms can be applied. And there you go. And that's my thank you. I don't actually have a slide that's the same because I didn't type it. There you go.
So Andrew said that he wanted questions during rather than after. So Alice and Andrew will be around. Firstly, thank you very much for the talk. It was absolutely